Well, today we are going to look into the second part of this tutorial series, which is that how to configure ROS1 with PX4. So basically, we have done detailed analysis in previous video that how in which technology, which operating system ROS1 or ROS2 is better for development of PX4 overall. We have seen different pros and cons, different trade-off between these two. So in the end, somehow we convinced that ROS1 is somehow has better support more than 1 decade, means that you find often solution of your errors. Plus, there are mostly there are some third parties repositories and a lot of work done by third party also in ROS Nordic, which you don't have to reinvent the wheel, but you can use that to develop your meaningful application using PX4, which is obstacle avoidance, environment mapping, and 3D environment mapping, navigation stack, local global planner, and all those things which are very important. And by the way, PX4 also don't support ROS2 for obstacle avoidance officially, but they do this for ROS1. So for ROS1 installation, you don't have to do anything, just what we have shown in the previous video. Similarly, you just have to install full desktop version with Gazebo and ROS, but make sure that Gazebo and ROS actually might get conflict when you install both of the systems on your machine, like ROS1 and ROS2. Sometimes they get conflict because they are using different client and different versions. So how actually you can really install the MavROS. Okay, so here is the thing. For ROS1, there is no communication client or any DDS or any direct client actually. So you have to take the advantage of MavROS. MavROS is middleware in this case, which is responsible for communicating from ROS to PX4. This is actually your middleware function. Well, great. This is not a big deal, yeah, because maybe you think that there is more customization and flexibility when it comes to ROS2, because it's just direct giving you a message out of PX4, and you can do a lot of stuff in a traditional way. But MavROS is somehow you have to stick to the only those functionalities which are somehow provided by MavROS or which are somehow available, and there is no room for customization. But honestly speaking, I think so it is enough when you are not actually writing any completely different thing what is available in Mavlink and MavROS. Normally it should be sufficient for most of the tasks, but yeah, for advanced development for sure MavROS is not sufficient, and that's why actually community is shifted from this to the second style, second more advanced technology, which is ROS2 with direct communication with DDS. That was the core reason actually. Okay, great. For installing this, you just need to open a terminal, because here for the easy they have written this environmental variable in between, but for me I'm using actually the both of the ROS1 and ROS2, so I have to make sure that this environmental variable, which is ROS distro, is set to Nordic, not Foxy. Okay, great. Then I can now paste this here. type my password. It's reading a package. Some of the packages are installed. Some additional package should be installed. Some dependencies. ROS extra and UID message, and these things are actually a little bit, more helpful for this ROS. So yeah, it's gonna take some time. Yeah, it's done now. Great. So what we have done, actually, we have first installed ROS1, and we don't need to reinstall or reconfigure the PX4, because as I mentioned earlier many times that PX4 is independent from the platform. You can use any technology, any platform. Yeah. So here, and there is no conflict between ROS1 and ROS2. So good. We are good to go here. So now I just need to install. So well, we're gonna work via launch files here normally. So it's more efficient to pack many nodes in master node and everything in launch and then launch it. Even we can call other launch file within the launch, and then this create a very good hierarchy of, in chain of the command in one go, rather than just opening 100 windows and shooting different initializations. Yeah, great. Okay, if we go into the launch file of px4 folder and launch file. So this is the launch file actually written there. So it says that, okay, which position should be your drone is, and what is the name of drone. I mean, as I have said, there are many different kind of drone. This is Iris drone. This is that was the company who built this Iris drone, but later on they went into bankruptcy somehow. But still, their model of simulation are widely used for drone testing. So it's a saying that, well, since the very important thing is to you have to add the px4 in your environmental variable and ROS distribution and ROS package path variable, because otherwise it's don't know that px4 where is px4. So and it will not be able to find this path mapling gazebo actually. So it says, well, you can change this argument as well. So these are the args. Simply you can change them in here. So you can load any any kind of this is the gazebo configuration. This is the Mavros. This is the Mavros default port here, right? Localhost. Later on, if we practically do this, we have to give complete, remote UDP of that. And this is the px4. So it's again including the px4's this file in it, which is nothing but it's telling that where is the launch D file, initialization file of the px4 is. This is here, and then it's gonna tell the different argument in this launch file. So if you have to supply any argument in include launch file, you can do like that argument. So if you're gonna give value of x here, it's gonna replace the value of x here somehow, this argument, and whatever argument name is same in this file and this file. So similarly, this is your pitch roll and everything, orientation of your vehicle. The word argument is arg word here. So your arg word here is given here, somewhere here. So here actually you can give the path of the word you want to load into. We'll see how you can customize this later on, how you can give any standardized you know, file, any word, any specific word. We're gonna work with warehouse word later on, and we'll give the customized word in it. So similarly, this is the, again, for ROS, you need to, I mean, this is the basic initialization of these drones spawning, and basic PX for um, PX for initialization, controller initialization, and this is then the basic PX for launch. If we see here again, this is the ROS file. So here actually we are giving the basic configuration for everything, and when it comes to ROS, we need to give it the GC URL. GC URL is by default. FC URL is URL we have decided here. So, well, I mean, default vehicle, and then if we go to PX4, is nothing but just saying that environmental variable of PX4 sim model, and it says that simulation lives in the gazebo classic slash whatever the name of vehicle is, which is ROS here. Going to this path here, if you see it here, might be this is that. What is the name of the build file? What is the name of the, and then stilt, well, and then gazebo classes is simulation model, and that's how it's actually find PX4, you see, then build, then stilt, then default, and it's automatically simulation model is this gazebo classic, and path, whatever the path of PX4 sim environment is, and the value append to it. That's how it's logically find everything. So it's gonna go here. It's the environmental variable of PX4 is always equal to simulation here. If we go to the simulation, then it's gonna come here. It's gonna always find for this classic, and then stilt, whatever the name of model is, stilt here, software in the loop, and the gazebo classic. And then this is the simulation actually, and name of vehicle is ROS, and I don't know. So yeah, that's how it's work actually. Okay, now let's see how we can do this. Well, if I go there, oops, I go there, because we have added this in the package, in the package of ROS launch, and we also have added in the catkin or catkin, then it should work. Well, if we see here, it says that this is the ROS launch server. I mean, this is the main server, and then it's giving us a lot more beautiful, ROS topics, which is actually way to handle everything, giving command or controlling your drone and everything. And then here are the nodes. Main node G, like gazebo server node is running on, client node is running on PX4, and somehow ROS. So yeah, great. So all the plugins which are needed are loaded here from Mavlink. This is good thing. There are some warning that too many subscriptions, we can safely ignore them. So the control of the vehicle is right now on board, not off port, and then we are good to go. So this is the annoying message. We can ignore this, but this is the time reset, time synchronization somehow, that for how long if the drone sit idle, it's gonna give something. Let's try commander take off and see something happen here or not. It's very dark. Okay, it's initially set to go to 5 meter, and our drone hover to 5 meter. Well, great. Now takeoff detected. Okay, great. If it's not taking off, we can say commander takeoff. Oh, sorry, not takeoff, but commander land. Otherwise it's gonna go 5 meter above and it's 10 meter high. You see, it's actually due to some single pointing laser sensors. It's first see the ground and then soothe itself and calm itself into environment, not just pumping on the ground, but just smoothly landing mechanism. Great, so I guess it's working fine with ROS1 as well. Now the next step would be the off-board control for both of kind of PX, both of kind of ROS1 and ROS2. We need to somehow manage to see how off-board control actually is working. So then we're gonna see how off-board control is working.